In the early 2000s, deep under the Iranian desert, inside a heavily guarded facility called Natanz, a line of gas centrifuges began to scream. On the control room screens, everything looked normal. RPM, pressure, flow, all green. But out on the floor, metal was tearing itself apart. Engineers rushed in, slamming emergency stop switches. Dozens of centrifuges were ruined, warped, twisted, useless. No bomb had been dropped. No missile had struck. The attack came from a place where no siren could warn them. From inside the code. Natanz wasn't just any facility. It was the core of Iran's uranium enrichment program. Thousands of IR-1 centrifuges spinning uranium hexafluoride gas step by step closer to weapons-grade material. To slow Iran down without triggering a full-scale war, the United States and Israel launched a covert program. Its codename, Operation Olympic Games. Its weapon, a piece of software designed to break machines in the real world. Planners had a brutal constraint. Natanz was air-gapped, no direct connection to the internet. So the weapon had to spread like a normal virus, hide like espionage malware, then behave like an engineer who knew exactly how the plant worked. The result was Stuxnet, a worm first discovered in 2010 but believed to have been in development for years. Unlike normal malware, its target wasn't your bank account. It was industrial control systems, the computers that tell machines what to do. Stuxnet spread through Windows machines, often by infected USB sticks. But it wasn't interested in most of them. It lay dormant, scanning silently for a specific fingerprint. Siemens Step 7 software talking to programmable logic controllers, the digital nerve system of Natanz's centrifuges. It exploited multiple zero-day vulnerabilities, previously unknown Windows flaws, to move laterally and escalate its privileges. 4 0 days in a single weapon. That's the software equivalent of firing 4 untraceable bullets at once. Cybersecurity researchers later called it a, quote, precision weapon. It was designed to ignore almost every system on Earth, unless that system was wired into a uranium enrichment cascade that looked exactly like Natanz. Once Stuxnet found a matching configuration, it did something no one had seen before. It reprogrammed the PLCs themselves, the boxes that directly controlled the centrifuge motors. Then it launched a man-in-the-middle attack. To the operators, the control screens showed stable speeds and normal vibration. In reality, Stuxnet was feeding the PLCs a different set of commands, and looping back recorded good data to hide the sabotage. Its payload was elegant and cruel. In one sequence, it gradually sped some centrifuges up to far beyond their safe operating frequency, from their normal 1064 Hz to around 1410 Hz, then dropped them to a few hundred Hz for nearly an hour. Metal spun faster than it was designed to. Aluminum rotors stretched, scraped, and in some cases, shattered. The worm then quietly returned the system to normal, letting engineers blame mechanical failure or poor quality control. And all the while, the logs looked clean. By late 2009, international inspectors noticed something strange at Natanz. A large number of centrifuges had been quietly taken offline, removed, dismantled, replaced. Estimates suggest around 1,000 machines. Nearly 1/5 of Iran's operational centrifuges may have been damaged or destroyed. Iranian officials later admitted that malware had caused problems at Natanz, though they downplayed the scale. Western reports, citing intelligence sources, pointed directly at Stuxnet. Inside the White House, according to investigative reporting, President Obama was briefed that the worm had spun out of control at one point, spreading beyond Natanz to other networks, yet still mostly missing its intended physical targets. He reportedly ordered the attacks to continue anyway. Stuxnet didn't stop Iran's program, but it slowed it. It forced Tehran to rebuild cascades, replace hardware, and question the integrity of its own systems, all without a single airstrike. The message was clear. From now on, code could do what bombs used to do. For a while, Stuxnet stayed in the shadows. Then, it slipped its leash. A programming error in an update is believed to have let the worm spread more aggressively than intended, jumping from Iranian networks onto the open internet. In June 2010, a small security company in Belarus, Virus Block Ada, noticed a strange new worm on a client's machine. Within weeks, Stuxnet had infected tens of thousands of computers worldwide, most of them in Iran, but many far beyond it. Researchers at Symantec and other firms began tearing it apart. What they found stunned them. Industrial sabotage routines, PLC rootkits, 4 zero days, stolen digital certificates, and meticulous logic targeting Siemens controllers. This wasn't cybercrime for profit. This was a state-level weapon, deployed in peacetime against a nuclear facility. For many analysts, Stuxnet marked the moment cyber warfare left theory and entered reality. And the most unsettling part? The weapon wasn't fully classified anymore. The code was out there, captured, reversed, studied. Neither the United States nor Israel has formally admitted to creating Stuxnet. But multiple investigations, from the New York Times, Washington Post, and others, have traced it back to a joint US-Israeli operation. Strategically, it achieved what it set out to do: delay Iran's enrichment program without dropping bombs. But it also did something its creators may not have intended. It showed everyone else how to do it. Since Stuxnet, governments and analysts openly talk about cyber tools that can shut down power grids, derail trains, or damage pipelines. Some have already been used in Ukraine and elsewhere, spiritual descendants of the worm that spun centrifuges in the desert. Stuxnet proved that you can use software to cross borders undetected, damage critical infrastructure, and leave just enough deniability to avoid a conventional war. In the end, Stuxnet wasn't just a worm. It was a proof of concept, a blueprint for a new kind of weapon, and a warning that the next war might begin as a silent line of code in a system log. This was Stuxnet, the code that rewrote modern warfare. Because sometimes, the most powerful explosives are the ones you never see.